Basic organic chemistry questions has been compiled and answers explained to enable you to know how to tackle CBT question. So make sure you subscribe to this channel and study this compiled past question to the end. Which of the following alcohols cannot be oxidized by permanganate? The answer is tertiary alcohol. How do I know tertiary alcohol? Tertiary alcohol, the carbon that bears the hydroxy group does not have any hydrogen or methyl. So C is the option. The following reagents are oxidizing agents except lithium aluminum tetrahydride, which is a reducing agent. Looking at the compound, the functional group is what you're going to consider when naming an organic compound. You give the functional group a priority by giving it either the first carbon or the minimal number on the chain. Looking at this, my carbon number 1 is carbon that bears the hydroxyl. Then second carbon is bearing methyl. Then 3 and 4. So I have 4 carbons in all, making it butanoic acid. In that butanoic acid, my carbon 2 is methyl, so making it 2-methyl butanoic acid. Propanal and propan-2O will give the same visible result with 2,4-dinitrophenylhydrazine, which is called Brady reagent. This in the lab, when an unknown organic compound is given and you want to verify whether this compound is a carbonyl compound, when you drop this 2,4-dinitrophenylhydrazine or Brady reagent, which is the common name, is going to turn orange. PPT will form orange precipitate, validating that this is carbonyl compounds. But if I want to distinguish between these carbonyl compounds, I can use oxidative reaction, which can be permanganate, chromate, or any oxidizing agent. Bertolus reagent is also an oxidizing agent used to distinguish propanal and propanone in the lab. Organic compound A is oxidized with hot acidified permanganate to give and react with sodium to give hydrogen. For a compound to do that, reacting with sodium confirms that this compound is an alcohol. So it must have a hydroxy group. And for it to be oxidizable, it can never be tertiary. So it's either primary or secondary. From the options, the best answer is A, which is secondary alcohol. Ethanol and propan-2-ol give a pale yellow precipitate of triiodomethane when reacted with 1 potassium iodide. The name of this reaction is haloform or iodoform reaction. The compound here is an alcohol and the compound form is alkyl halide. How do we do exchange of hydroxyl anion with chloride anion? The only thing that can do that is inorganic acids, which can be PCl3, PCl5, thionyl chloride. HCl is not among the inorganic acid, so that is option of except. Grignard reagent form primary alcohol when reacted with methanol. Ethanol and propanol is going to form secondary. Propanol is going to form tertiary. The catalyst and product of Friedrich-Crafts acylation reaction is ketone as a product, and the catalyst is aluminum trichloride. Carbonyl compound react with hydrazine to form hydrazone. If it's 2,4-dinitrophenylhydrazone is a reaction when carbonyl reacts with hydrazine, 2,4-dinitrophenylhydrazine, that's Breda reagent that form the orange PPT. That orange PPT is 2,4-dinitrophenylhydrazone. Oxime is formed when carbonyl compound reacts with hydroxyl amine. In this reaction above, we have phenol being nitrated with 3 mole of nitric acid. Remember, phenol don't need conc because it is already activated by hydroxy group. So whenever SS is used, both auto and 1 para are being nitrated. So we are going to have 2,4,6-trinitrophenol. Phenol more acidic than alcohol, in this case ethanol, is because the phenoxide ion is stabilized by resonance, and there's no resonance in alcohol. In Williamson's synthesis or preparing ether, what are the best alkyl halide? It can be primary, it can be methyl. Secondary and tertiary is not always good. Tertiary is never used. Secondary is not always good. But the best is primary and methyl halide. So the option is D, which is I and IV. The following reactions can be used in preparation of alcohol except dehydration. In dehydration, you are preparing alkene. The compound above, the IUPAC name of the compound above, seeing this compound above, in CBT, look at the quick way of doing it. The compound is phenol and all the options are phenol. We are doing the elimination reaction. Then in terms of alphabetical order, which one beats alphabetical order? Realize bromo and chloro. D is 4 bromo and 2 chloro, which is perfect in alphabetical. Others alphabetically are wrong. So, but in exam, if all are alphabetically okay by arrangement, then look at the numbering. Since hydroxy group is a functional group, I have to go clockwise or anti-clockwise to give this substituent a minimal number. So because chloro is there, I have to go chloro before bromo and methyl, so as to get but when naming them, I will name them alphabetically. That's why bromo will come before chlorine. The hybridization of carbon in alcohol is sp3. The following are the characteristics of tertiary alcohol, except that it can never react with chromic acid, which is an oxidizing agent. So anything that has to do with oxidation, tertiary alcohol is not there. Others are correct of tertiary alcohol. The hybridization of oxygen in alcohol, ether and oxide are sp3. Because they are all saturated bonds. While the bond angle of oxygen atom in ether is higher than that of alcohol, which is 111. Which of the following cannot be oxidized by permanganate? The same thing, this is like talking about, I think this question has been repeated, so it's still the same tertiary alcohol. The compound above. If I want to name this compound, the first thing I have to look for in CBT exam is a clue. Number one clue is that the hydroxy group must have the minimal number. Coming from my right, it is 3, from my left is 4. So I have to go for the option that gave me 3, and there's only one option. I'll pick it up and go. So C is the option. In alcohol, the effect of hydrogen bonding is strongest in primary because the hydrogens, alcohol have the carbon that bears the hydroxy group has 2 hydrogen. Because of that, these hydrogen are available for bonding, unlike tertiary and secondary. So tertiary is the worst because there's no hydrogen. So hydrogen bonding is very limited. This compound that will experience highest boiling point is one that will have highest hydrogen bonding, which is primary alcohol. Component of rubbing alcohol is propan-2-ol because propan-2-ol is called rubbing alcohol. Alcohol can be synthesized in the lab using the following method, except synthesis gas. Synthesis gas is used in preparation of alcohol in the industry. While aldehyde on reduction gives alcohol, and oxide when react with greener reagent gives alcohol, then alkane under hydration gives alcohol. 2 alcohols can be produced when dash undergoes reduction. When esters are reduced, you're going to form 2 alcohols. Remember, esters are formed by carboxylic acid reacting with alcohol. That alcohol functional group is going to be reduced to alcohol. While the carboxylic functional group is going to be reduced. Remember, carboxylic acid are a product of primary alcohol, so they're going to form primary alcohol. So the other end depends on the class of alkyl halide that is there. It depends on the class of alkyl, the alcohol that forms the ester. So we're going to have 2 alcohols. Or cannot be synthesized. Secondary alcohol can be synthesized by greener reagent using the method, greener reagent method using ethanol. Methanol and oxide is going to prepare primary. Propanol prepares tertiary. So all alkanal except methanol is going to form secondary alcohol. The chemical properties of alcohol include the following, except chemically, amphoteric means it can react with acid and base, which is a chemical reaction. Reaction with active metal like sodium to liberate hydrogen is chemical. Reaction with Lucas is chemical. Ability to undergo intermolecular hydrogen bonding is not a chemical reaction. So the answer is D. Looking at this reaction, we have 2 mole of alcohol under dehydration at 140 degrees using sulfuric acid, forming a product called ether. Why? Because it is incomplete dehydration. Phenol can be prepared industrially using Cumming process. Diazonium salt is used in preparation of phenol in the lab. Starch fermentation is for alcohol. Decarboxylation of salicylic acid is none of the above. The product formed when phenol is treated with excess bromine is the same thing of nitration. Both auto and para are being brominated. So we have 2,4,6-tribromophenols. What type of reaction is dehydration of alcohol? Elimination reaction, because you are taking away water. The type of reaction where 2 mole of alcohol is dehydrated is called dehydration reaction. When propanol move to propanol without forming propanoic acid, we call it limited oxidation, because propanol, which is primary alcohol, under oxidation are supposed to form propanoic acid. So when propanoic acid is not the target, we want to limit our oxidation. We don't use any other oxidizing agent except pyridinium chlorochromate, which is called PCC, because if I use chromic acid, it's going to form carboxylic acid. Jones reagent and permanganate, they are all going to form carboxylic acid. Only PCC is going to limit it to alkanal, in this case propanol. The possible mechanism in dehydration of primary alcohol is E2. In E2, just like SN2, everything happens at the same time. So the type of reaction whereby phenol is distilled at high temperature to form benzene is called reduction reaction. Why is ether more volatile than alcohol? The reason is because there is presence of intermolecular hydrogen bonding in alcohol, which make alcohol to be very polar. And ether does not have it. That's why ether is non-polar. When anything is non-polar, it has a tendency of being volatile. When ethyl isopropyl ether undergoes acid cleavage with conc HBr at an elevated temperature, the pair of products formed are one. Now, ethyl isopropyl ether is going to have 2 parts. One is ether, the one that they carry oxygen, the other one that normal ethyl. So that other one that does not have any oxygen is going to take bromo to become bromoethane. While the other one that has ether is going to take hydrogen to form alcohol. So we're going to have isopropyl alcohol and bromoethane. Alcohols can form carbonyl compound except tertiary, because tertiary cannot be oxidized. The reaction that converts alcohol to carbonyl are called oxidation reaction. because reduction converts carbonyl to alcohol. Carbonyls react with potassium cyanide to form cyanohydrin. This cyanohydrin, under hydrolysis, acid hydrolysis, is going to form carboxylic acid. The following reagents are reducing agents, except potassium permanganate, which is an oxidizing agent. Hydrogen in palladium, platinum, or nickel are all reducing agents because hydrogenation is a reductive reaction. The reaction above is talking about silver mirror. This is when carbonyl reacts with Tolune's reagent to form a carboxylic acid. It is an oxidative reaction, and this is only possible with aldehyde. Ketone cannot react with silver mirror, cannot react with Tolune's reagent. So the answer is the product is the reaction above is typical of silver mirror. If an option of typical of Tolune's reagent is also correct, but in this case, it's silver mirror. Alcohol reacting with ethanol reacting with propanoic acid with corn sulfuric acid as a catalyst is going to form an ester. The name of ester formed by the reaction is ethyl propanoate, because when ester is formed, the part that is going to be the ester, that is going to have the ester name, is going to be carboxylic acid, while the alcohol part is going to form the alkyl part. So the alcohol is ethanol, which makes ethyl, while the ester is propanoate, making it coming from the acid. So we have alcohol first before acid parts, making it ethyl propanoate. The following reaction differentiate aldehyde from ketone, except ketone reacts with filling solution, while aldehyde does not, because ketone can never react with fillings, which is oxidative reaction. Ketone is stable to oxidation. Identify the reagent A in the following reaction. The reagent is corn sulfuric acid because water is being removed. And the name of the reaction that we've seen in the previous slide is the hydration reaction because water is being removed. The following are characters of aromatic compound, except number 1, they obey Hooke's rule. They must be cyclic, they must be conjugated, and they must be planar. So non-planar is not a character because they must be planar. So the option is C, as except. The bond breaking that generates radicals is known as homolytic fission. Cannot be fusion is coming together, fission is breaking apart. Heterolytic fission is when we are generating carbocation or carbanion. So anything fission is breaking apart. Fusion is coming together. When an electron cloud between atoms are symmetrically disposed to each other, the bond is said to be non-polar bonding. A typical example is chlorine molecule or hydrogen molecule. So the electron cloud is the same everywhere because there's no difference. So they're going to share it equally, making the compound to be non-polar. Bond breaking, which involves equal sharing of electron, is called homolytic. Which of the following statement is not correct for a nucleophile? A nucleophile is never a Lewis acid. A nucleophile is a Lewis base. Ammonia is a nucleophile. A nucleophile does not seek electron because they are electron rich. A nucleophile attack low electron density site because they have SS, so they go to one that does not have electron, which are electrophiles. But nucleophiles are Lewis base, not Lewis acid. So the answer is A. Which of the following is the most deactivating metal directors? they are NO2. NO2 are the most deactivating, and deactivators are meta-directing. The order of increasing nucleophilicity is bromine. Now, if there is fluorine, fluorine will come before chlorine, chlorine will come before bromine and iodine. So the smaller the size, the higher the nucleophilicity. Homologous series of alkanol have the general formula of CnH2n plus 2O. Because CnH2n plus 1 is alkyl, so the remaining one hydrogen is going to bond with oxygen to form the hydroxyl, making it alkanol. Find the compound which undergoes nucleophilic substitution reaction exclusively by SN1, benzyl, because of carbocation that is possible with benzyl chloride. 2-bromopropane reacts with hot conch solution of sodium hydroxide in ethanol. The product is going to be propane, in the sense that the sodium, which is a base, is going to come and take the acidic hydrogen, which is hydrogen next to the alkyl halide, and bromine is a good leaving group. As it's taking it, bromine is leaving, so double bond is being formed, which is involved in the mechanism of a reaction between aqueous sodium hydroxide and 1-bromo. Remember this reaction, this is primary alkyl halide, so it can never be carbocation. So B, C, D miss it because of B, and D miss it because of carbocation. Then this can never be homolytic because bromo can only be heterolytic. So that's why C is off it. So the answer is attacked by a nucleophile on a carbon atom with partial positive charge. The compound above, if I want to name this compound in CBT, I'll look at the functional group is benzamide. It's an amide. And because it's benzene, aromatic ring becomes benzamide. Then I'll look at the naming. When I look at the naming, something is common. 5-bromo is common. 2-hydroxy is common. So the problem is methoxy and methyl. So which comes first? Methoxy comes before methyl, so B is the best option. The reaction above is the reaction of aldehyde with hydroxylamine, and is a condensation reaction to form oxime. The reaction of acyl chloride and aromatic hydrocarbon in presence of Lewis acid is known as Friedel-Crafts acylation. If it's a reaction of alkyl chloride, it's going to be Friedel-Crafts acylation. Rules below can be used to determine if a compound is aromatic. Foucault's rule. Markovnikov's rule is a rule to use to add hydrogen halide in unsaturated system. Arrange the following phenolic compound in increasing order of acid strength. Phenol is an activator and electron rich. So any compound that will take electron from it, make it very acidic. Anyone that releases electron to it, make it very weak acid. So the strength of acid will be more with nitrogen, which is electron withdrawing and deactivators. So in that case, 3 is the strongest, followed by IV, then followed by V, followed by phenol. Because methyl is electron donating, is going to be the least. So the option is C. The reaction of Grignard reagent with an epoxide gives primary alcohol. Not just primary alcohol, but primary alcohol with 2 carbon added is the most appropriate. In exam hall, if you just say primary alcohol, you didn't read all the options, you will not see the last option, which is the most appropriate. Primary alcohol with 2 carbon atoms added. Carboxylic acid can be obtained from Grignard reagent by treating with CO2 and HCl. If you look at this option, you realize that there is CO2. There's another CO2 with HCl. There is another CO. It cannot be carbonate because we are looking to add double oxygen to form a carboxylic acid. That's why it has to be CO2. And if I form my CO2, I have to do hydrolysis to add hydrogen to it. So that's why HCl is coming. So D is the option. The name of the compound is, if I see this compound is in the exam, what is going to give me an idea is the nitrogen. Is nitrogen being accommodated? Is only accommodated in C, where we have NN-dimethyl. So this gives me options. Others are wrong. Acid chloride is going to form an aldehyde. Remember, it's a reductive reaction. I cannot use any other reducing agent. It's a special reaction. So I have to use tertiary butyl oxide in lithium aluminum tetrahydride. That is the reducing agent I need here. Alcohol, carboxylic acid, and carbonyl are identified by the following respectively. In the lab, alcohol can react with sodium metal, like we saw in the previous question. Carboxylic acid is sodium hydrogen carbonate, while carbonyl are Brady reagents. Brady reagents are 2,4-dinitrophenylhydrazine. Hence, C is the answer. Nitration of nitrobenzene will give 1,3-dinitrobenzene because nitrobenzene already has NO2 already, and NO2 are metal directors. So any other nitration coming will go to carbon number 3, making it 1,3-dinitrobenzene. The typical reaction of benzene is electrophilic aromatic substitution reaction. Which of the following compounds undergo haloform or iodoform reaction? Remember, for a compound to undergo haloform or iodoform, alcohol and carbonyl can do that. But the alcohol or carbonyl must remember it must be, why alcohol is that this is an oxidative reaction. So the alcohol is converted to carbonyl, and they must have a methyl attached to the functional group. So in alcohol, it's only ethanol that can be reactive with iodoform reaction. While in carbonyl, we can have any carbonyl that has methyl attached to the functional group. So one cannot because ethyl is being attached to functional group. Two can because we have two methyl attached to the carbonyl functional group. Three can because the terminal methyl can react. When under oxidation, you're going to form a ketone. You are having terminal methyl attached to the functional group. IV cannot because it's ethyl. YV can because it's ethanol. Under oxidation is going to form ethanol, and in ethanol, the carbonyl is connected to methyl. So the answer is 2, 3, and 5, which is C. An ester on reduction with lithium aluminum tetrahydride yield a mixture of propanol and propan2-ol. This ester is isopropyl propanoate because the propanol is going to be oxidized. It's going to be the part of ester that form an acid. Then propan2-ol is the alkyl aspect. So remember, propan2-ol is also called isopropyl alcohol. So we have isopropyl propanoate, which under reduction is going to form propan2-ol, which is isopropyl alcohol, and propan nol, which is from propanoic acid. A crown ether containing 18 total atoms and 6 oxygen atom in a ring is called. Now, when you talk about crown ether, the number of atoms is equivalent to the number of crown. So if I have 18 total atoms and 6 oxygen, I'm going to have 18 crowned 6 ether. If I have 12 total atoms and 6 oxygen atoms, I'm going to have 12 crowned 6 ether. So it is just the simplest thing to know. So don't ever fail question on this ether. The name of the reaction that involves two aldehyde to form hydroxyl aldehyde is aldol reaction. When this product is dehydrated, we are going to form alkenyl. The carboxylic acid is confounded qualitatively by sodium hydrogen carbonate reacting to liberate CO2. In the reaction below, the preferred mechanism is SN2. Remember, in SN2 is a concerted reaction. So it means that in this substitution, everything happens at the same time. We are forming an ether, so the substitution occurs at the same time. There's nothing like transition. Remember what we are dealing with, primary alkyl halide. So there's nothing like transition. So it's SN2. Which is more acidic of the following? The one that halogen is closer to the carboxyl functional group is going to be more acidic by inductive effect. Reduction of alkyl cyanide or nitrile is going to yield primary amines, not just amine, but primary amines. Hydrolysis of diazonium salt is going to yield phenol. Under hydrolysis, that diazonium salt bond is going to cleave and is going to be replaced by hydroxy group to form phenol. Why? When nitrile are being hydrolyzed, they can either form amide or carboxylic acid, depending on the option. From this option, acid chloride can never be, because it can never form anything chloride. So the best option here is amide. The most stable carbonium ion is tertiary, because in terms of benzene is more stable than allyl, but tertiary is more stable than all. Which of the following show positive inductive effect? Methyl, because of electron donating potential. Nucleophilic substitution reaction of unimolecular, that's SN1 mechanism, take place via two concurrent steps, because concurrent means one after the other. It can never be tandem, it can never be concerted, and it is not one step. An acid derivative reacts with alcohol to form an ester and an acid. This acid derivative is an acid anhydride. That's what we saw in the previous slides when we are talking about acetic anhydride reacting with methanol. The following are factors that affect acid strength. Structure of the compound can affect acid strength. Inductive effect can affect acid strength. Hybridization and energy of the compound can never affect acid strength. The product of reaction of alkyl chloride and aromatic hydrocarbon in the presence of Lewis acid is alkyl benzene. Remember, the same Lewis acid, aromatic hydrocarbon with acyl chloride, is going to form ketone. Which of the following compound will have the highest boiling point? Because of hydrogen bonding, carboxylic acid. In absence of carboxylic acid is primary alcohol, but in this case, carboxylic acid, so C is the best option. Which is the most acidic? Remember, phenol is activator, so anyone that releases electron will make it weaker. Looking at all are releasing except NO2 that is taken, so NO2 is most acidic. Benzene, despite the presence of double bond in this structure, does not undergo addition reaction. Why? It is not because the rings are cyclic, because cyclic alkane can undergo. It's not because benzene is not aromatic, because benzene is aromatic. It's not because only 6 hydrogen atoms are in the compound. No, the reason is because this double bond and single bond in the ring are in alternate position. So there is no particular place you can say these bonds are. And another reason is that benzene refuses to undergo addition reaction because it wants to maintain its aromatic character. Because when benzene undergoes addition reaction, it's going to form cyclohexane, so it will cease to be benzene. So this is 2 reasons, depending on the one that comes in the option, to avoid losing the aromatic character, or because the bonds are in alternate position. So there's no specific place for double bond and single bond. Which of the following is not a method of preparation of carboxylic acid? When you oxidize primary alcohol, you're going to form acid. When you oxidize substituted alkyl benzene, you're going to form acid. Hydrolysis of nitrile will give you an acid. The carboxylation means removal of carboxyl, can never give you an acid. The following would be oxidized to propan-2-O. Remember, prop, but cannot because butanol cannot. 2-methyl cannot. 2-methyl already is tertiary alcohol, which is stable to oxidation. Ethanol is primary. So the answer is propan-2-O, forming propan-2-O. Which of the following is the strongest Bronsted acid? Phenol is strongest Bronsted acid. Remember, it can be stabilized by phenoxide ion can be stabilized by resonance. Which of the following is the strongest Bronsted base? It is not aniline because the number of electron is not available. It is cycloamino because this number of electron is available for donation. In the dehydration reaction of propanol in the presence of sulfuric acid at 170 degrees, the product formed is an alkane. Remember, if it's at 140 degrees, we are going to form an ether. The product of the reaction of phenol with diazonium salt is called azo dye. Azo dye is the dye they use in industry to dye materials. The following alkyl halide can undergo Williamson synthesis except 2-bromo-2-methylbutane because this is tertiary alkyl halide. Much I want to encourage you, if at this stage you've not subscribed, subscribe to Dr. Anita Kem, and also click on the notification button so you'll be notified. The second part on this section 213 compiled past questions will be released very soon. The essence is, especially people that are carrying this course over, study this, drop your questions in the comment section. It will be attended to. If you're familiar and understand why you're choosing any option, it will help you to answer any question on CBT as regarding basic organic chemistry. I wish you success in your CHM 213 or any basic organic chemistry exams. See you in the next class.